a funny irony in the high-end analog world. You can invest in a legendary, masterful engineered turntable like the Technics SL-1210GME, but if you rely solely on basic alignment, tools included in the box, you are leaving the true magic of that deck completely untouched. To get absolute peak performance out of a table of this caliber, we need to go beyond the basics. So today I'm going to walk you through exactly how I calibrate the SL-1210GME using precision instruments from Wally Tools to dial in a cartridge alignment, azimuth, overhang, and anti-skating. If you don't take the time to properly set these microscopic geometries, you aren't just missing out on ultimate audio fidelity, you actually run the risk of unevenly wearing down your expensive stylus and your favorite records. Let's get into it. So the manual of the 1200 GME has some great info for setting tone arm height based on your cartridge height. It has the ability to change the arm lift height if need be. You can adjust the turntable startup speed. You can adjust break speed. There is info on balancing the arm and setting anti-skating. To set anti-skating, set your tracking force first, following the cartridge manufacturer's recommended specification. The table will not come with a scale, but I can show you one that you can get on Amazon right here. They cost about $25. We'll put a link down below on how you can get yourself one of those. And essentially, as a general rule, you're going to set your anti-skating dial to the same number as your tracking force. But we will check this in time with the Wally Skater. So this is just basically the way you're going to do some basic setup if you weren't going to go to this level of caliber of precision alignment. So the manual's got, like I said, all kinds of cool information, enough to get you started, enough to deal with simple cartridges. And by a simple cartridge, let's take a look at this Audiophile Concord Black. Okay, so this is about as simple as it gets, right? There's no head shell for this cartridge. Everything is aligned and set up. Essentially, you go to the S-shaped arm on the Technics turntable, and all of the Technics turntables, not just this one. Screw it in, and you're pretty much done. Now, what you can do is you can balance the arm, set the tracking force, set up which counterweights you're going to need. You can also do some minor tweaks here. You'll notice if you unlock this a little bit, you can rotate the cartridge slightly back and forth. So you can do some alignment checking, and I've got a cheap alignment tool here. This is not the one we're going to use today, but you can pick up one of these. We've got these on sale from Audio Technica on our website. But essentially, you can check the alignment on a simple cartridge like this by loosening this up, aligning it, spinning it back and forth to see if it's aligned on the two different points for overhang and alignment of your cartridge. And for the most part, you're golden. You're good to go, right? Between that, balancing the arm, getting the traction force based on setting up your counterweights, and then setting the anti-skating weight to the traction force of this cartridge. I think this one is 2.5. Most of the Audiophines are 2.5, so you'd set that at 2.5. And it's simple, but we want to go way beyond this, right? This is an ultimate level turntable, and we want to tweak this out. And what I'm tweaking it out with, this is the Audiophile Cadenza Bronze moving coil cartridge. Not a cheap cartridge. I think the retail is $25.99 if I'm not mistaken. We'll put it up on the screen in case I got that wrong. I'm also going to use the LH9000 head shell that Audiophile makes to match with this. Now, I've already set up this cartridge based on all of the Wally tools we're going to talk about. So this is perfectly set up in terms of I'm actually using a shim on it, and we'll get into that in a few minutes. A shim to make sure that you change your different angle of alignments of the cartridge so that you get the perfect setting onto your a record, and so that you don't cause undue wear, you don't damage the stylus, you don't have an imbalance between right and left channels, all kinds of other stuff. So I've set this up. I've also set up a bunch of other mock pieces here to use in my explaining over the process. And the Technics turntable will come with its own cartridge. A head shell, sorry, not cartridge. I chose not to use it. I wanted to use the Audiophile head shell to go with the Audiophile cartridge. I also am using here, and we'll get into this. This is the Wally reference, which is for setting up the leveling of your arm. And here I'm using an Audio-Technica AT-LH-15H. And 15 stands for the weight of that head shell. And I've got some other head shells here. Here's the 15. They make an 11. They make about, I think there's 5 altogether at different weights, depending on your cartridge weights and about balancing. I've also got one of Audio-Technica's cartridges here. I don't have the head shell here with that mounted. I was going to use that as an example, but that's being used in another video right now. There's an overhang tool that comes with the Technics turntable, but I found it was not very accurate for any of the cartridges I've set so far. If you have no other tools like the Wally Tools or other way to check for overhang, this is a great place to start in terms of, and the way this works is that you put your head shell in here and you've got a cartridge on here and you want your stylus to basically line up at the end of this, and that's sort of a baseline, if you will, for setting up overhang. But on a turntable of this price point, we're not going to use that. But by all means, when setting up a less expensive turntable from Technics, and they've got turntables that start at $7.99 and go all the way up to this Mac Daddy one, on those cheaper decks, it makes sense to use that because you don't want to spend a ton of money on all these Wally tools, which are not cheap, but they do, they are going to do reference quality setup and alignment. At this price point, I think spending extra money for tools to set the deck up for peak performance is well worth it. You can also ask us to set the table up for you. Reach out to us for more information. For the sake of this video, we'll use the Wally reference to level and balance the arm. I showed you that a second ago. Okay. We'll use the Wally tractor, which I've already got the disc here. And this is for setting up all alignments of the cartridge and overhang, etc. Moon Audio has no affiliation with Wally Tools or WHAM Engineering, which is the proper company name, but we can help facilitate the measurement or calibration process of a cartridge for you. We can handle all of this from start to finish. We do the bulk of the work in-house. We'll send off the cartridge you purchase from us to JR at WHAM Engineering. He can take care of all the measurements that we did on our cartridge, on our Ortophon, to get it set up for shims and to get this reference quality alignment. If you want to go the extra mile, I would send that cartridge off to JR at WHAM to have it measured and shims manufactured to get the perfect alignment on your cartridge. Balancing or leveling the table by adjusting the feet on the table is first and foremost the most important thing, okay? So I've perfectly set this up. And I don't know if we can see this in the cameras, but in both directions, I've got it balanced with the feet. So that's the most important thing to do first. Some of these levels are cheap and aren't accurate. Try and buy one that that's been set up to be perfectly accurate. Test this against other levels to see if it matches up. I then add painter's tape to prevent the platter from moving. So a couple of pieces you can do for, you really only need 2. We don't want this to move at all when we do any sort of work on here. Actually, I'm going to turn this over for a second. The first thing is preparation and measuring for cartridge height, okay? So let's talk a little bit about the cartridges I have on hand. First of all, the Concord, you don't have to do anything for measuring for height. This is a plug-and-play cartridge. But for the Cadenza by Ortophon, we do have to measure for height for setting up proper balancing of the arm. Every cartridge has a height. So essentially, we're going to put this cartridge on here, and we're going to pretend that I don't already have the shim installed, okay? And we're also going to pretend that I have a record on here. Always make sure to lift the arm. You don't want to just drag your arm over, drop the needle, and damage it, okay? So, and probably put this in the middle somewhere. So we're going to drop the arm onto the backside of the Wally tractor. And the reason I'm doing it on the backside is the front side is a mirror and very easy to scratch the glass. I've already done a couple of scratches so far, so I don't want to do any more. So I propose in some of the things that we do, you turn over the Wally tractor so you don't scratch it up. Wally will send you, or JR, not Wally. JR will send you a whole bunch of different little tools that come with all of these different setups. And one of them is a little ruler for measuring the height of a cartridge. And so we're going to place this on one side and we're going to measure the height between the bottom, essentially where it's sitting, up to right at the bottom of the head shell. And then we're going to do it on the other side because the head shell might be slightly out of alignment, and so the numbers might be different. And so we want to get an average number between the two sides to figure out what the height is. Let me lift this up. Like I said before, with this locking collar, if you loosen a little bit, you actually get a little bit of play so that you can, if you want to balance the height, but it's not really necessary for right now, you can do it. Okay, so we've mounted the cartridge in the middle of the head shell slot, and we're going to set the vertical tracking force to the middle of the manufacturer's recommended range. Now for this cartridge, it's about 2.5, and it's probably going to vary right now because I've got a lot of different things going on here. We're at about 2.39. I'm not going to make any adjustments. I've done adjustments a couple of times. For the sake of time, we're just going to show that you need to do that at the same time that you've just done your height, okay? So I place the ruler as close as possible to the cartridge without touching it, right? I measured both left and right. I check for being as close to the nearest 0.25 millimeters. If they differ, I said, let's take an average and determine your final cartridge height. Leveling the head shell is next, okay? So here we're going to remove the cartridge, and I'm going to put a little protective sleeve on here because I do not want to damage my stylus. Okay, always do that as much as possible. Leveling the head shell using the dual axis blade, okay? So let's remove the cartridge and attach the dual axis Wally reference blade to the head shell. The updated Wally reference blades are exactly 15 millimeters tall. You must use stacking shims between the blade and the head shell to perfectly match your measured cartridge height. Now, my measured cartridge height also included a shim here, so I've actually added an extra shim here to add for that account on the cartridge. As part of the analysis report that you get, he goes over what all the cartridge heights will be for resin, metal, and we'll get into showing the different shims later. But essentially, for the metal corrective shim, I'm using the brass one, I need a cartridge height of 21. So essentially, this all adds up to 21 millimeters here, okay? So let's remove cartridge. Install this. I like to keep it a little bit loose because remember, there's a little bit of play. I'm going to put this over here while it's flat. Now I'm going to adjust that, okay? And so if you press down on any points, none of this shows any light under it, okay? Slightly in the front right. Loosen that up. But when I set this up, I was using the Ortofon head shell, which is slightly different, to set this up. And so everything, when I did that, was perfect. So essentially, you're going to get down on the floor and you're going to look to make sure that you don't have any daylight. If you have daylight, then essentially what you're going to do is adjust the height of the tone arm, okay? You're also, like I said, doing some adjusting on this locking mechanism. Once I'm done, I'm not going to remove this cartridge anymore, okay? For the sake of what we're doing in this video, this is going to get removed. But once this is set up and I've gotten this all flat, that Ortofon cartridge stays here. So let's go ahead and take this off. Let's pretend like we've already taken care of all those measurements. We've balanced the arm. We've set the counterweights with the tractive force. And now since there is some play in this, I'll have to go back later and check this. For the sake of argument, we're going to pretend that this is all flat and leveled now, okay? So if you don't have the Wally tractor, you want to place a warp-free record of average thickness onto the platter. Ensure the tone arm clips will not touch the record. Those are the wires hanging from the back. At first, when we're going through all of the setup, you may want to leave all of these wired connections dislodged because you're going to be doing some moving and adjusting of the cartridge and they can get in the way. And obviously, you don't want those underneath the Wally reference. Like, see, here you can see now, these can get in the way and they can get underneath the shims. So that's what we're talking about there. Make sure that those are out of the way. The Wally tractor is perfectly flat. You don't have to worry about variations in platter pads or records, which can be warped or have variation in height if not a quality pressing. And you don't really want to use your best pressings to do this work. Accidentally scratching it will bring tears. Trust me, I've scratched a few really nice records in my time. So you lower the blade onto the record. You add tracking force if the blade is too light to lower properly. Looking at the record level, adjust your tone arm height and azimuth until the blade's bottom edge touches the record flush along its full length on both axes. Note that adjusting the height can alter the azimuth, so you may need to go back and forth until you are perfectly flush. Your tone arm is now perfectly parallel to the record. So again, I've already gone through and done all that with this, and this was perfectly set up. I'm going to have to go back and do some checks after this because obviously by doing all these different factors, I've screwed with what's going on here on the arm. Next is adjusting SRA and VTA using the front and the back of the blade. Now, there are extra pieces that come with this to do that. But since I went ahead and did a cartridge analysis with WHAM Engineering, and I sent off my cartridge, and essentially this is the whole point to this shim, is it gets you out of dealing with adjusting the SRA and VTA, okay? Which is a very time-consuming and a very painful process. By getting this shim made, the shim is essentially milled down in two different directions based on the angle of your stylus and all of the measurements that WHAM Engineering takes here on the cartridge analysis report. So they essentially make it very simple for you guys. I'm not going to cover the SRA and VTA. The Wally reference comes with the tools to set this, rather than adjust this manually and most likely have human errors, as it's not a simple, easy task. I opted for the Wally shim option, okay? Available in a cured resin, milled brass, or now a stainless steel. So here's an example of the resin, okay? And you'll see it says front up, so that means when we place it on here, it needs to go in that direction. The curve points are always facing forward, and then it's got, looks like a serial number so that you can tie it to a cartridge. This is the brass shim, and I've got a second example here. It's a little bit, you'll notice it's a little bit shorter because we're also dealing with mass, right? This is super light. This has more mass than the resin. And I've already installed the final version of what's going to go on here, but that's what those look like. Okay. And these corrective shims allow you to correct your SRA and VTA at the head shell. I went with the brass and the cured resin. Each has an associated cost. I would recommend from an engineering standpoint, either the brass or stainless steel. I have thoughts on the sonic effects of each, but until I play with them all, I can't give perfect feedback yet. It's important to optimize your SRA and VTA at the head shell and not by using the tone arm height. Because by changing the tone arm height, you're changing multiple vector forces in addition to influencing the SRA and VTA. Further, since the average VTA correction is 7 degrees to 9 degrees, and a target of 20 degrees maximum or 18 degrees optimal, no tone arm can accommodate this correction in any case. You need help by these shims. So let's now get to the cartridge alignment. So here we're going to turn back over the Wally Tractor. This is where you do all of your alignment. The Wally Tractor Universal is the cartridge alignment protractor that features arcs specific to the tone arm you own, as well as the tone arms you may own in the future. Preparations and safety. Okay, this is funny. JR says you should make sure to work sober and carefully. What a great statement. Plan to move slowly and deliberately to protect your fragile pieces. All of this stuff, especially your stylus, is very fragile. Make sure you preset tracking forces, disable your anti-skating, and set your vertical tracking force to roughly the manufacturer's optimal specification for the ortofon. Cadenza bronze is around 2.5 grams. Ensure your tone arm is free of static friction and excessive horizontal torque. You can do this by working with the Wally Skater. We'll talk a little bit about that later on. Level the head shell, which we have already done with the Wally reference. Okay. I've talked about, again, the adjustments going on with this locking collar, and some of this will come into play when setting up the alignment on the Wally Tractor. Okay. So first, determine your effective length. Technics states that the effective length is 230 millimeters. I found this to be incorrect, and I'm assuming that was a rough estimate. Identify your tone arm's effective length, not the pivot to spindle distance, in order to use the prescribed arc on the Wally Tractor. So we're going to use the provided pivot to spindle ruler. Place this on the center here. and we're going to line this up over the pivot point. Now, I roughly got around effective length of 232, plus or minus a little bit, right? So essentially, on the Wally tractor, there is no 232. There's a 231, there's a 233.15. So actually, I'm going to use both to check all of my alignments, okay? So you plug this pivot to spindle measurement into the calculator on Wally Tools website to get your exact effective length and round to the nearest figure on the Wally tractor. Again, I can't round to the nearest one because I'm sort of almost perfectly in the middle based on the numbers. So this is between two of the alignments on the protractor. I'm going to check both, okay? Next, we're going to set the overhang. To set the overhang using the Wally tractor versus the Technics piece, okay, and this tool, there's another tool to do overhang. They're okay, but neither of them are great. Place the Wally tractor on the spindle. We've already done this. Notice that each effective length arc actually consists of two lines close together. One for Burwald alignment and one for Lofgren alignment. Choose which geometry you want to use. There's no right or wrong here, okay? I use the Burwald. They're close enough to each other that I don't know that it really makes a difference, to be totally honest. You can get into the white papers understanding more about the two of them, but either one's going to do you just fine. So swing your tone arm to the outer perimeter of the Wally tractor or at point 0. And point 0 is on the edge. And I'm going to pretend that I don't have this protection on here because I want to protect my stylus. I've already set this up again. Okay. So at this point here, we're going to get out this wonderful magnifying glass that they gave with us. And we're going to check where the stylus is on that line. And I would use your cueing arm and move the stylus to the inner area of the arc at point 1. Never spin the Wally tractor while the stylus is resting on it. You could scratch things. So I'm going to look at now the 10x loop to evaluate where the stylus lands when I drop it down, okay? I'm going to loosen the head shell screws and gently push the cartridge back towards the pivot. If it undershoots, pull it forward. Return to point 0. Rotate the tractor so the stylus falls into the arc again and recheck point 1. Using the optics can be a bit challenging. Play around with it a little bit. You're going to see at different angles, like I always try to get it lined up with the line at a perfect parallel alignment with the line. And that way you can see for parallax. And parallax is what? This is a mirror. And the lines that are etched on the top are also reflecting to the bottom. So you have lines that move like this. One on the bottom, this is the one etched on the top. You want to move your eye so that you line these up. And that'll make sure that all of the measurements and adjustments you make will come out very well. Now, I've already done all the adjustments for this, so I am just going through the motions. For close-up views of what these points look like, please see Wally Tractor videos 1 through 3. And we're going to put all the links below to all the videos and the PDFs of the instructions so you can see if this is worth your time. After we do point 0, we're going to come out here to point 1. I think we talked about point 1, but I didn't lift it and move it. But we're going to check it there as well. And what happens is if your stylus, it's perfectly on the line here, but when you get to the inside, it may not be perfectly on the line. So that's where you've got to unscrew the screws, adjust and tweak the alignment of the cartridge to get it to land. Then you bring it back to point 0, check it again. Then you take it back to point 1, check it again. It's a constant process of fiddling to get the cartridge in the right place. I was very lucky in that I got it almost spot on the first try. I had to make a slight adjustment on the inner screw where I had to tweak that a little bit, and then it was good to go. Next, we align the cantilever at the null points. And we've got 2 sets of null points, and it's based on arm length. The arm length on the Technics is 9-inch, so we're going to use the 9-inch null points, okay? Move the stylus to point 2, the first null point, and lower it to the center of the 3 triplet marks for your chosen alignment, Burwald or Lofgren, okay? So it'd be right here. We're just going to pretend that I don't have the protector on there. Again, we're going to use the magnifying glass. Again, we're going to look at parallax. Again, figure out how to hold this so you get the best view. Everybody's going to do it differently. I actually hold it a little bit like this when I view it. The angle gives me a better view of the lines. Look from the side to ensure the stylus is resting exactly on the radial line that extends from the edge to the center of the tractor. To eliminate parallax error, look straight down at the mirrored surface, adjust your viewing angle, right? Talked about that here, until the laser etched alignment mark perfectly lines up with its own reflection. Check if the cantilever is parallel to the alignment lines. If it's not, you're going to do some adjustments by unscrewing again and making changes. You may then have to go back and look at these other lines that we did for the effective link arcs. Again, it's a back and forth process, okay? If it is angled, keep one cartridge screw snug. I kept the outer one snug. I loosened the inner one. And gently revolve the cartridge clockwise or counterclockwise, depending on what you're doing. Again, we already set this up. It's good to go. Tip: for micro movements, watch the ends of the cartridge pins in relation to a fixed point like the arm wand to gauge very tiny rotational adjustments. Once aligned at point 2, I'm going to spin it a little bit here. Or actually, you won't spin it. You're going to take it to point 3. Again, we're going to line it up on the null line and the protractor cross line. And we want to make sure that that needle drops right on that point where they cross over at both points on the null. Now we want to verify the maximum angular error points. So then we're going to move to point 4. With parallax error eliminated, look at the cantilever. You should expect to see a slight clockwise angular error of approximately 1 degree. Now move to point 5. Here you should see a counterclockwise angular error. This is noticeably greater than the error you saw at point 4. If the errors don't match this expectation, i.e. if they are equal but opposite, or if point 5 is huge while point 4 shows nothing, you need to return to the null points and refine your alignment again. Again, it's a back and forth process. After you're done with the null, I went back and checked over here again. Then I went back here. So let's go over some important numbers I received back on the WHAM Engineering Cartridge Analysis Report. I'm not going to go over all of the numbers, as a lot of these numbers are used for background calculations. They're not necessarily needed for the setup. Wally Tools has a great video that goes over all of these numbers in depth, and I don't want to recreate the wheel for the sake of keeping this video not too terribly long. You will receive your analyzed cartridge back from the lab. It comes with your corrective shims that I showed you earlier, right? The corrected shims mechanically implement your optimal angles, though if your tone arm can independently achieve the required stylus rake angle, SRA, and vertical tracking angle, VTA, you can use the Wally reference single blades instead of installing the shims. I'm going to use the shims. Like I said, trying to do that was just way too cumbersome. I'm an engineer. I like that this is made to very specific nomenclatures, okay? Reviewing cartridge heights at the top of your report, you will find 3 distinct height measurements. You've got the actual cartridge height. For the Ortofon, it's 18.5 millimeters. You've got the cartridge height plus the resin corrective shim, 20.25 millimeters. You've got the cartridge height plus the metal corrective shim at 21, okay? And again, all of this is accounted for when we do the balancing of the head shell on the Wally reference. These figures are crucial because they dictate exactly which thickness shims you will need to stack on top of your Wally reference to achieve the exact distance needed to accommodate your cartridge and chosen shim. Wally, or JR, analyzes SRA and VTA results. SRA handles the horizontal modulations of the stylus, while VTA handles the vertical modulations. The lab must strike a balance between the two. He then reviews the azimuth results. The report notes a visual stylus azimuth orientation, just to see if the stylus looks mounted, but you should never align for optimal azimuth optically. Instead, the report relies on electrical measurements. WHAM balances 3 elements to find an optimal azimuth. Next, correcting the zenith error is looked at. Zenith error is an angular deviation from true perpendicularity. The report indicates if this error is clockwise or counterclockwise from the perspective of pointing the stylus directly at your eye. Looking at the end of the report to find 2 specific line items telling you exactly which radial lines on the Wally Zenith tool to use to align your cantilever. So, let's show you the Wally Zenith tool. Now, this tool is a little more complicated. There's no way at the moment to electrically measure this with their tool setup, okay? But essentially what you're doing is once you've aligned everything, okay, you're going to check to make sure here's the record groove and your needle is right in the center of the V. If that needle is slightly bent, you're going to have an imbalance between the left and right channels. And that's what you're doing with this zenith thing. You're checking, looking at alignments, and there's lots of lines here at different angles. Essentially, you're going to look at your cartridge analysis report and find where your zenith error is. With the corrective shims and without the corrective shims, we found it to be at 3.5. So I'm going to use this 3.5 line right here, and I'm going to look for angular deviations. Now, I specified 2 lines. Well, why 2 lines? One figure is for alignment without your corrective shim, and one is for the alignment with the shim. Because the shim tilts the cartridge to implement azimuth, it creates a visual illusion, making the cantilever look misaligned at the null point. WHAM uses trigonometry to calculate exactly which Wally zenith line will bypass the visual error. So let's get the zenith tool. Okay, so it looks very much like the Wally tractor. And so we had a measurement of 3.5. Here's the 3.5 alignment. And so we're going to spin that here. We're going to get our magnifying glass out and we're going to look at, here's your V notch in your turntable. I mean, in your record, right? The stylus is in the center. Now the stylus can be bent slightly. And when it's bent slightly, what happens? Well, we've got an imbalance in the gain of the right versus left channel, okay? So using this tool to effectively look at, okay, is there any angular change here that we need to adjust for? Your shim adjusts for most of this. But what I showed you earlier is, well, this locking collar has a little bit of variation. So you can use that to balance what's going on there. Now, at this point, Wally has not created a electrical methodology for measuring the change between the left and right channel. This will be part of that process. Now, he does say that people are able to use this tool and make adjustments to the angle and actually hear the differences. We'll see. I'm going to try it myself and we'll see if I can hear those differences. I would imagine if the adjustment is like a hairline, who knows? I can't imagine it being much. So once again, I've already gone through all of the steps to balance the arm, raise the height to balance the arm, change the counterweight to adjust the balancing of the arm, installed the cadenza on an Ortofon LH9000 head shell. We've checked for zenith error. We've checked for overhang with the tractor. The only thing left to do now is anti-skating. Now, anti-skating is a little bit more complicated. I'm going to show you the tool. Let me remove this and remove this and install the Wally Skater. Now, as I said, I've already done this as well, but we're going to show you how it looks. There are 2 little adjustments up here that you play around with to raise and lower things down. I'm not going to get into major adjustments here, okay? The Wally Skater is to help you ensure that all of your hard work on aligning your cartridge isn't impacted by your tone arm. The Wally Skater is used to measure the optimal anti-skating force. If you don't have this tool, as I said earlier, a good reference point is to match your cartridge tracking force number. It's the only device that accurately measures tone arm horizontal forces, including anti-skate force, and helps check the health of your tone arm bearing and the mechanical resistance from the tone arm wiring. Be sure to use the Wally Skater before aligning your stylus, back at the beginning, or cantilever. This will help confirm that your tone arm isn't affected by the cantilever angle. Make sure anti-skating is at the 0 point when starting these measurements. It's a great idea to check your tone arm periodically, like I'm doing here at the end of the process, to keep everything running smoothly. Now, once you've done that, use the Wally Skater again to set the proper anti-skating force before measuring for the ideal azimuth angle of your cartridge. Getting your anti-skating just right is crucial for aligning the stylus within the groove. right in that V, ensuring even compression on the cartridge suspension system and protecting both your stylus and your record grooves, because you can wear out the edges if not set properly. So let's be sure to set that anti-skating correctly. Remember, this calibration process takes a little time and patience, but the incredible tight engineering tolerances of the Technics SL-1210GME actually make using these Wally tools so much easier. Once you learn how to quickly do this, you can swap out cartridges and unlock the absolute highest tier of analog sound and make this hobby so much more fun. If you'd enjoyed geeking out over this deep dive into turntable setup, make sure to hit that subscribe button down below for more audio engineering walkthroughs. Now that your turntable is perfectly dialed in, you should learn about the science behind these tools. I recently sat down with J.R. Bosclair from Wally Tools on Fidelity Exchange to discuss optimizing analog gear and what every high-end turntable owner must consider. Click the video on your screen right now and I'll see you there.